method to simplifying a complex rational expression, what we're going to do is we're going to find the least common denominator of the entire expression. So what we'll do is we'll look at each fraction individually and find the least common denominator of it. And then what we do is we take that least common denominator and we multiply it by the numerator, the top of the fraction, and we multiply it by the bottom, the denominator of the fraction, and it cancels out the fractions within the fractions. So it sounds more complicated than it is, but it does take a couple of examples more than likely to understand what is happening. I am going to make our division line just a little bit darker here, because what we have here is we have x over 2, x divided by 2 minus 1, and then divided by x minus 2. There's actually 4 parts to this complex fraction. It's complex because this x divided by 2 is a fraction within a fraction. But the rest of it is that this is 1 over 1. This is 1 over 1, and this is 2 over 1. Sorry, x over 1, and then minus 2 over 1. We don't really need to write those values. But what we are going to start with is, what's the common denominator between these 4 individual fractions? Well, there's only one place that really has a denominator. It's the 2. So I'm going to show a little bit more work than you probably need to see, but we're going to take 2, which is the common denominator. Where did I find what? What's in common between 2, 1, 1, and 1? So we found that the common denominator is 2. And what's going to happen is we're going to take that common denominator and we're going to multiply it by every individual term within this fraction. So we're multiplying 2 by x over 2. We're multiplying 2 times 1. We're multiplying 2 times x. And we're multiplying 2 times 2. So what we're multiplying by, the LCD, the least common denominator, is in red. And we're going to multiply that by the original problem, which is in black. And what happens when we multiply every piece of this fraction is this 2 here, 2 divided by 2, cancels out, and we're left with 1x. 2 times 1 is 2. 2 times x is 2x. And 2 times 2 is 4. So we found the least common denominator. We multiplied it by all of the parts of the complex fraction. Are we done?
No.
What has to happen now? And it doesn't always happen, but it looks like, if we look at our denominator, that we can use our skills from yesterday, which says that we have something in common. We are factoring the GCF of the denominator, and it's 2 times x, and then 2 times 2 is 4. So to finish on this problem, do we have anything exactly the same in the top and in the bottom of our fraction? Well, x minus 2 and x minus 2, which means when we finish here, we actually ended up with 1/2. And again, this stuff, because I'm teaching you a shortcut method, I didn't teach you the long way first and then the shortcut method. It takes a couple of examples to see, but I think that we'll be fine by the end. So on problem number 2, again, I'm going to put a darker division bar in so you can see this. This time it's x minus 4 over, or divided by, x over 4 minus 4 over x. So, but the thing is, we need to find the common denominator And if you prefer, we can write this problem as x over 1 minus 4 over 1 divided by x over 4 minus 4 over x.
Are you sensing a 4x?
And good, sensing a 4x is a good thing, because we don't know what x is. So our only option is to take the two denominators that we really have, the 4 and the x, and multiply them together. And we can make it a little bit shorter here in terms of work, is once we determine that the LCD is 4x, we're going to take 4x, and we're going to multiply this term by that. We're going to take 4x and multiply, whoops, put my parentheses around the wrong part there. I don't know if that'll work or not. Nope. Try this. 4x there. Third time's a charm, maybe. Easier said than done. 4 times 4x. But we have to multiply all of the parts of the fraction. We're going to multiply this by 4x, and we're going to multiply this by 4x also. And the thing is, we don't really need the 1 in the denominator, but now that we have all of this, 4x times x is 4x squared. Minus 4 times 4x, which is 16x. But we're luckier in the denominator of this complex fraction because 4 divided by 4 is 1. And we're still left with x times x, which is x squared. And then over here on this last part, the x's. X divided by x is 1. And we're left with 4 times 4, which is 16. So now it looks like we can simplify again. And sometimes we can simplify and sometimes we can't. But I think it's good practice from what we were working with yesterday. So what's in common in the numerator? The greatest common factor is a 4x. And we're left with x minus 4. Down here in the denominator, it's the difference between two perfect squares. X squared is x times x. 16 is 4 times 4. Difference between two squares, different signs. And then to finish, we ask ourselves, do we have anything exactly the same in the top and in the bottom? Well, x minus 4. So we're going to end up with 4x divided by x plus 4. If you took Algebra 2 last year with the math instruction, we did do a lesson or more on this.
Got one more.
As we look at problem number 3, once again, what we need to determine is what's the least common denominator. And it doesn't have to be the least common denominator, but it's easier if it's the least common denominator.
Are you sensing an x squared?
And it is. We look at the x, and we're going to look at the x squared, and we're going to take the highest exponent to be our least common denominator. So the LCD is x squared. And once again, I hope that you don't have to write it all over again, but I think that the color coding helps a little bit. So what we're going to do is we're going to take x squared and we're going to multiply it by 6 minus x squared times 5 over x, all divided by x squared times 1 plus x squared times 5 over x squared. And as we take a look at this, Let's try to cancel. Well, x squared times 6, we don't have anything to cancel. That's going to leave us with 6x squared. But over here, and if you need to, remember, x squared is x times x. There's two of them. So when we cancel here, what happens is that one of the x's cancels. So we're left with x times 5, which is 5x. Down here in the denominator of our complex fraction, we have x squared times 1, which is just x squared. And luckily over here, we have an x squared in the numerator and an x squared in the denominator. They cancel out, and we have plus 5. And as we look at this, we could factor the numerator a little bit, but there's really nothing else we can do to cancel because x squared plus 5 doesn't factor. So as we take a look at the next one here, now we have two variables in this, but we still need to start with what's the least common denominator. So if you look at the y's between y and y squared, it's going to be y squared. Between x squared and x, it's going to be x squared. And I know that I just wrote that as x squared y squared for our LCD, but you could have written y squared x squared. It doesn't matter. What we're going to do then is we're going to multiply every fraction in here by x squared y squared. It's going to be x squared y squared times 3x divided by y minus x squared y squared times x divided by y squared. LCD, x squared y squared times 2y divided by x squared, and x squared y squared times y divided by x. So once we get that, and to be perfectly honest, I never write this when I do this. I just fill it in right in the problem the best that I can. But when we cancel here, let's do the easy part here for a minute. And the easy part being, we have a y squared divided by y squared. That's an easy part. And on this term here, we have an x squared and an x squared. They cancel out. But once again, I want to point out that y squared, if you need to, is y times y. As we go back to this first term, and we're dividing by y.
Just slice off
Slice off one of them.
Slice off the square.
So when we simplify that, it becomes y the first. It works the same way over here.
Just cross off the square.
And it's the same thing, you're right. What's simplifying? We have x squared divided by x. If you're confused with the exponents, write it out long version. X times x is x squared divided by x. And then again, we can slice off, as he said, one of the x's. So now when we put this back together, we've got x squared y times 3x, which is 3x cubed y. The y squared's canceled out, so we have x squared times x, which is, again, x cubed. Down here in the denominator, we were able to cancel out the x squared, so we have y squared times 2y, which is 2y cubed. And we've got one x left, x to the first, times y squared times y, which is x, y cubed. So I don't think that we can cancel anymore, but let's try just to make sure. What we see as a greatest common factor up here in the numerator is x cubed. And then we're left with 3y minus 1. Down here in the denominator, we can factor out a y cubed. But it's not going to help us. We're left with 2 minus x. Because remember, what we're looking for if we want to cancel is, do we have anything exactly the same on the top and on the bottom? And we do not have anything exactly the same on the top and the bottom. So I am fine with this answer, but I'm also fine with this answer. Remember, they don't always cancel. They don't always simplify.
Why is the denominator have the xy cubed? Shouldn't the x be the only word in cube?
So now on these last couple, what I did is I put something that's added or subtracted in the denominator. But it doesn't change the method here, which is we need to know what is the LCD. And the LCD on this problem is going to be whatever is added or subtracted, which in this case is the x plus 1, times the monomial in this case, which is x. All we can do, we can take x plus 1 and we can multiply it by x. So I'm not even going to multiply it out. I'm going to multiply, and by the way, I do want to show you how I work these out just to maybe save you a little bit of time. So what I do is, once I determine what the LCD is, I write right here. I write x times x plus 1. And I write x times x plus 1. And I write x times x plus 1. So it depends. If you're a big writer, it's probably easier to write it out like I've been doing on the previous examples. But I just write it right beside there. And what happens is that the x plus 1s cancel out in this first term. Our x's cancel out in this second term. And the x cancels out down here in the denominator. So we were able to get rid of the fraction within the fraction, which is what our goal is truly supposed to be. And we're left with x times 1, which is x. And over here, we're left with minus x plus 1. Be a little bit careful right there, because it's minus in front of what's left. Down here in our denominator, we're left with x plus 1 times 1.
I mean, isn't the sign of some relevant? Because we can just multiply in a negative 1.
The sign is important because we need to distribute that. And when we distribute it, we get x minus 1 over x plus 1.
Well, I see that we have some right terms.
And we have like terms, x minus x, which is another part that happens to cancel. So we end up with negative 1 over x plus 1. Can't do anything else. So as we get close to finishing here, what's our LCD?
X. Oh, it's x plus 4.
X times x plus 4. And again, to save a little bit of space and time here, I'm looking up that I can make this bigger. But all that we really need to do is we're going to multiply every term in this complex fraction by x times x is 4. And we're going to multiply it by x times x was 4. Every term. So this one, x times x was 4. And over here, x times x was 4. So we're going to have to simplify a little bit more here in a couple of minutes. But when I rewrite this, the first part with this 2, it's really going to be 2 and then x times x was 4. Plus, over here, our x's from the denominator, it cancels out, and we're left with 5 times x was 4. As we look in the denominator of our complex fraction, it's going to be 1 times x was 4.
Now,
And I'm going to put the 1 in there. We don't really need to write the 1, but there it is anyway. And then over here, we get our x plus 4's cancel out. So it's going to be plus 1 times our x. And again, we don't really need to write that 1.
so I'm guessing we drop the x plus 4's 2x plus 5 equals 2x. And then
How about we distribute here? So we get 2x squared plus 8x.
then plus
Distribute here. 5x plus 20. I don't know where I'm losing you.
the fact that wouldn't we have had to put that into that form in order to get it to where we already had it? It seems like we're just undoing what we've already done.
Oh, what we were doing is we were getting rid of the fraction within the fraction. So now we just have a top and a bottom instead of 2 plus a top over bottom divided by 1 plus a top over bottom. Let's keep going here. X times x is x squared plus 4x plus 1x. But now what we have is we just have a single numerator and a single denominator. We don't have a fraction within a fraction. And when we simplify this a little bit more, we get 2x squared plus 13x plus 20 divided by x squared plus 5x. And now the question is can we factor this part?
Yeah.
And we actually can,
And then
but I'm not sure that it cancels here. But that's the issue. I mean, sometimes it works out for us and sometimes it doesn't. This one actually, just to save a little bit of time, if we factored it, it doesn't, there's nothing that cancels. So I'm going to leave it at that and just tell you that. If you want to see the factoring, we can talk about that later. Because at the very least here, I want to get this last one set up for us. But it's not really much different from the previous two. I just wanted to make sure that we had enough examples, because I don't think in Algebra 2 we really did any with an x minus 1 or an x plus 4 or an x plus 1 in the denominator. But what is our LCD here? X minus 1 times x. We take the monomial, the single term, and we multiply it by the binomial, the one with the plus or the minus in it. So it's going to be x times x minus 1. And then we're going to multiply x times x minus 1. we're going to multiply x times x minus 1. We're going to multiply x times x minus 1. Every term, whether there's a fraction there or not, we have to multiply by. And then we can cancel. The x's cancel out, and we're left with x minus 1 times 1, if you prefer. In our next term, it's plus 2, but our x minus 1's cancel out, so it's 2x. In our denominator, x minus 1 cancels out, and we're left with 5x. And then it's plus 3x times x minus 1. Nothing cancels out there. As we simplify then, we end up with x minus 1 plus 2x. And you may have already written the 3x minus 1. Down here in the denominator, we have 5x plus 3x squared minus 3x. So if we simplify that a little bit more, we end up with 3x minus 1 over 2x plus 3x squared. And can we do anything else to that? We cannot. I mean, we can factor out an x of the denominator, but because we can't factor anything in the numerator, there's nothing else that we can do. All right.